Today we're going to talk about zero trust for IBM. Zero trust is a very common cybersecurity framework, and it's widely used to help protect against the overwhelming surge of cyber criminal activity we've all heard about in recent years. And it basically employs the concept that no one inside your network is really trusted anymore. And it implements stronger identity and access controls to protect against if users are compromised. But even though zero trust is very popular now and quite effective, we do still continue to see a lot of IBM servers left out of the picture when it comes to implementation. So we're going to start off today looking at a few myths we often hear about why this may be the case. Number one, we have enterprise level security software, so we don't need to worry about securing the IBM server. This may be the biggest myth that people get caught in. For example, they might have a firewall for their corporate network. They might have MFA required at the corporate level. They might also have monitoring software on all the platforms except for IBM and have not implemented any zero trust on the IBM. However, this is a big mistake because most, if not all, enterprise level security software does not have specific coverage for IBM. This means that the IBM, including its integrated file system or IFS, it can be a breeding ground for any kind of ransomware, viruses, or malware, and it's often left completely unsecured and unmonitored. Number two, our IBM is in the cloud, so we don't need IBM security. We see a transition of a lot of small to mid-sized customers moving away from on-prem servers and into the cloud. Typically, a cloud provider will provide infrastructure level security. Again, a VPN connection, and they'll probably have SOC 2 compliance implemented on the infrastructure, which is great. And it's great to be in that infrastructure, but it can also lead to a false sense of security, thinking that you don't have to worry about security on the IBM at all. Usually in a hosted environment, when a cloud provider is offering a secure cloud, they're talking about securing the infrastructure. They're not going to implement or monitor the endpoint or the LPAR level security that you need to protect your data and operations. That's where you need to make sure not to neglect the IBM from a zero trust perspective. And the third myth goes something like this. Why do I really need security? We don't store any social security numbers. We don't store credit card data on our IBM, so it's not really necessary. And it is true, a lot of IBM servers don't store this type of sensitive data. However, a lot of mission critical applications are running on IBM servers, and proprietary information is built into the workflows to keep the business operations running. So those are intellectual properties that need to be protected. A key thing to consider here, if you are still in doubt about whether you need security, just think of a scenario where if for some reason your IBM is down for 3 hours, or let's say even a day or more, and those mission critical apps and operations and intellectual properties are not available. If they're stolen, if they're corrupted, if they're otherwise unavailable, what's the business impact going to be? Is your business going to suffer? What's the cost to the downtime? And what's the cost to recovery? Those are the kinds of things that implementing zero trust security helps you prevent, and why it's critical to implement zero trust on your IBM server. Now here we're going to go through a typical corporate security configuration. We're going to assume there is a corporate level security policy, and we're also going to assume there are software products implemented at the enterprise level, and that MFA is in place. Since most people work remotely, a typical scenario is that an end user will connect in the morning through MFA authentication. Then they'll connect through a VPN to the corporate network, and that will enable them to have access to all the corporate assets and resources. Usually it's a heterogeneous environment that people work in. They'll have access to Windows servers, SharePoints, Linux servers, where most of the applications probably reside. And also, there could be an IBM server in the mix. In most cases, if there is an IBM server in the environment, most of the corporate workflows and the essential operations reside there. In this example, this end user here will have full access to all of these resources. Now, there are many entry points for malware or a virus or ransomware to get into your system. If you look at security statistics from various organizations, phishing is still largely viewed as the most prevalent way an attack happens. So we're going to walk through what can play out in a phishing attack. Again, this is just one scenario. Phishing is one of the top methods hackers still use, and it's a very low-cost way of attacking a corporation or an end user. But keep in mind there are many other methods where systems can be attacked. In this example, a user gets a phishing email, and the user clicks on the bad link in the email. And it contains a virus, a malware, a ransomware, and it's downloaded to the user's workstation. Then that virus, malware, or ransomware that just infected the workstation will then try to attack all the other servers it can see on the network and attempt to reside on all those possible locations. In this example, the Windows and Linux servers were secured because they had software running to block potential attacks, and they could have probably also implemented many layers of zero trust security. Something to remember is that a lot of these corporate security software packages, like common ones are CrowdStrike or Arctic Wolf, they have agents for Windows and Linux and other common platforms, but there's no connectors for IBM. So in this scenario, like we often see, the IBM was neglected in the zero trust security implementation, and no software was installed, no security configuration was done, and there was no monitoring set up on the IBM. The attacker was able to find a weakness, connect to the IBM and become resident on the IBM IFS, even though, as you can see, the end user was authenticated through an MFA layer and was connected to a VPN. In addition to that, we've also seen situations where that virus or the ransomware that becomes resident on the IFS then goes on to affect the corporate network as well. So without a software or protection layer or software here, nobody is going to suspect or have the means to check whether the virus or the ransomware is hiding out on the IBM. It could sit there for who knows how long, and it could just continue to try to find a weakness within the network. The good news here is that there are several layers of protection that can be implemented to help secure your critical data and your critical operations that are running on the IBM. Now, there's no magic bullet to this, but the more layers you have, the better. Remember, the whole definition of zero trust is that you really trust nobody. That's because when something like a ransomware attack is trying to penetrate your systems, basically who you think is your end user is really not your end user. The user's workstation has been hacked, and the hacker is the one using your end user's credentials to do malicious activity. So even though your employees may be very trustworthy, the concept of zero trust includes putting safeguards in place to protect your assets in case a user is taken advantage of in a situation like this. The goal is to put up as many blocks as possible to make it as difficult as possible for a hacker to penetrate corporate resources, and also to limit the possible amount of damage that can be done if there does happen to be a compromised. Next, we're going to look at some different layers of protection that can be implemented. First, you have the corporate perimeter security, things like your corporate firewall, your VPN, your MFA authentication. The IBM server with your intellectual property, operations, mission critical, and confidential data is inside this environment. So we're going to highlight a couple of layers here in this approach. The first layer we'll talk about is the most important one, the IBM network security layer. So this would be the first layer that someone would have to pass through to access resources on the IBM. This is not the corporate firewall we're talking about here. This is a layer inside your corporate network that can protect your IBMI at a more granular level based on what operations and users perform through different protocols. These can be multiple protocols. It could be ODBC or JDBC connections. It could be SQL scripts, FTP connections, Telnet connections, or different web apps connecting to your server. And this layer can monitor all the network activity to the IBMI coming from all the different protocols within the corporate network. And it can restrict end users to only have access to the particular protocols or services and resources they need to enable them to do their authorized day-to-day operations. You have to make sure you're securing your network layer from unauthorized activity. For this layer, you can implement an IBMI network security exit point solution to make sure only the relevant activities from relevant IPs and operations are allowed to be performed by each user. And you can block everything else. This protects against malicious activity, and it also protects against accidental misuse by your users as well. Now, let's say, for example, for some reason, somehow your network security layer gets bypassed. You want to have another layer of protection. The second layer of protection here is object authorities and IFS permissions. So in this layer, what you want to do is implement the least privilege model. Like in the previous layer where you're locking down the network access, here you want to limit the end user's access to the IFS files and directories, as well as to native objects like your sensitive commands and programs and database files. The whole goal here with least privilege is that you want to minimize the risk of any end user who's been compromised and limit the damage that can be done from that user having excessive authorities. So often when we talk to companies about implementing security, we find Star Public authorities wide open. Star Public, as you may already know, is everybody on the system. And when the authorities are left wide open, it means everyone on the system has access to whatever resource it is. And we also often see IFS permissions to files and directories set to where everyone has read, write, and execute permissions. So anyone can do anything on the IFS. That's why it can be so easy for a ransomware to pick up residency on the IFS. We've seen, even on sensitive libraries, Star Public authorities being set much more excessively than needed. So in the scenario of a ransomware or malware coming in, it's very easy for those viruses or ransomware to become resident on the IFS. Even at the object level, for example, QSIS-2 data can be breached easily if you're not protecting at the object level and IFS level. And again, there are multiple layers that can be implemented. Here, we're just highlighting two main critical layers, but you can also have additional ones. For example, you could implement a privilege escalation layer where you only allow certain users to be granted increased special authorities for specific reasons, so they inherit a higher privilege to do specific operations. Then you can have another MFA layer. So although authentication is already required at a corporate layer or level, you may want to require MFA authentication for every remote server access to the IBMI. And you could also reduce the privileges configured at the user level, which would be another layer of protection. So with these protections in place, a user has to get through multiple layers of security to reach the crown jewels on the system. Excuse me. And that significantly decreases the risk of a security breach. Users can no longer directly access them just because they have access to the server in the network. The more layers you have, the more protection you have, so the better the zero trust implementation. Now, assuming zero trust is implemented on the IBMI, let's walk through that phishing attack scenario again. Windows, oops, here we go. Here comes the virus or the ransomware. And we see that the Windows and the Linux servers still have security software running and they're still protected. Then the ransomware attempts to penetrate the IBMI, but in this scenario, we have implemented a multi-layer protection approach. Exit point security protected at the first layer, then IFS security and object level security was also implemented. All those layers protect the IBMI from being penetrated in this phishing attack. So if you have any questions regarding implementing Zero Trust in an IBMI environment, or if you don't know what you currently have implemented or you need help strategizing, please let us know and we'll be happy to help.